Hello folks, today I have a wonderful question which also has got wonderful answer, often asked by many students. So of course I deal with those things which is asked by students, and this is for A-level students and +2 students. It is for general knowledge, some higher knowledge, not general knowledge, higher knowledge, and for people who are appearing in entrance examinations of several institutions or colleges. For them, it could be a very, very valuable resource. So it says that we have a capacitor in which whole part of the plates are not overlapped. So we have a capacitor in which whole part of the plates are not overlapped. So it is somewhat like this. So there's only some part is overlapped. So here we can see here, this part is extruded, only this part is overlapped. Now, if I go through the area, only A2 area is overlapped. Here A3 area is outside. No other plates overlap it, and same happens to A1 as well. If so, then what would be the expression for the capacitance? So the formula for capacitance is, as you know, C equal to epsilon naught A by this D. D is this separation. So let me say it is parallel. Wherever it is overlapping, it is parallel. So that's why D is same for all. So if I say vacuum inside, it is epsilon naught. And if it is not vacuum, then the expression will be C equal to epsilon of the medium A by D. So A is the area. Now here, which area represents that A? Is it A1? Is it A2? Is it A3? Is it A1 plus A2? Is it A2 plus A3? Is it A1 plus A3, or is it A1 plus A2 plus A3? So there we have multiple choices here. So here, what we have to know is that let us learn something about parallel arrangement. In parallel, what we have is, we have one capacitor here, we have another capacitor here, and we connect them like this. So this is plus, 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 and it is minus, minus, minus. We connect like this. Now, what if I connect, instead of the wires, if I connect this plate with this and this plate with this? If I do so, what will happen to the capacitance? Nothing happens. It's because these plates are also conductors. So joining them with this conductor and joining by themselves will have no effect at all. So that the capacitance will be same. So here we have got parallel of these two, the capacitance directly adds. And if I connect this to this and this to this also, the capacitance adds because the area adds. So here, what happens now here is, this thing can be divided into three capacitors. So one capacitor is this, the middle one. The middle one capacitor is like this, in which, so this is one capacitor in which the area is A2. And the separation here from here to here is D. Now we have another capacitor, this thing, and it's another plate is so far that, let me say this is so far that it is infinity. So its another plate is at infinity. So this capacitor. And again, for this thing, we have got the plate, this plate is here, which is area A1. So let us say this area is A1 and this area is A3, like this. So we have got this plate here, and it's another plate, the negative one is at infinity. So let me draw it here, and this is at infinity. So this minus is at infinity. So let us draw plus here. So this is 3 pluses plus 3 minuses. Here I have got 5 pluses, 1, 2, 3, 4, 5. This should be 5 minuses. Here I have got 5 minuses, and I should have here 5 pluses. So this is at infinity, this is at infinity, and this is at D. And all these three things, so there is direct connection here, they should be parallel to each other. So these things should be altogether parallel to each other, and this thing should be parallel to each other. Now, what is its capacitance? It is C epsilon naught A1. So here C1 is equal to epsilon naught A1 by this D equal to infinity. This is C3 is equal to epsilon naught A3 by infinity. A3 because the area here is A3, and its capacitance is equal to C2 is equal to epsilon naught A2 by this D. So here this is 0, this thing is 0, and this thing is also equal to 0. The only capacitance remaining is this. So in parallel they add up. So this capacitance, this and this add up, which ultimately give C equal to epsilon naught A2 by this D. So that means the only overlapped area counts, overlap portion counts. So it should be epsilon naught into that overlapped area by that separation. Now this thing is used in tuning capacitors, the tuner circuits in radios that we had in our fathers and grandfathers time. So what we do like this is we're actually varying the capacitance. So what happens is it has lots of plates like this, overlap plates. So when I do like this, the overlapped area changes. If I do this, the overlap area is huge. If I do this, decreases. If I do this, decreases. If I do this, it decreases more. So when the overlap area changes, the capacitance changes, and according to that capacitance, the device will allow some waves, some frequency, and disallow others. That's what a tuning circuit does. So this theory has that impact in tuning circuits.